Good morning to all. Today we will start a new topic under computer organization and architecture. So, I will cover little from the Hayes, but mostly from the amateur, and then again I will move to Hayes. So, I will specify that which portion I am teaching from the which book. Okay. So, topic is data representation. Okay. So, I said in the earlier class that information we while giving the definition of computer system, we talk about the information might be two type. Information might be two type. One is instruction, another is data. For data, actually there are computer scientists mostly focus on data representation. So, data can be number, or it can be non-numeric, again number can be fixed point number, or it can be floating point number, and fixed point number can be binary and then decimal. Okay. Similarly, this can be binary and this can be decimal. So, in today's class we will specify we will be knowing that how the fixed point number can be represented in computer system. Okay. So, therefore, our focus will be fixed point and obviously the binary representation. Okay. So, in the last class we talked about the word length. Therefore, while representing the number we should talk about in how many bits number, how many bits should be reserved for representing a number. Okay. For fixed point representation, we can represent the number in three ways. One is something called sign magnitude. Okay. Other way we can represent is called 1's complement, and 2's complement. So, sign magnitude, as name suggests, one bit will be reserved for sign of the number and rest represent the number. So, now we will talk about what is fixed point. So, fixed point number is like the point that is either a decimal point or binary point will be fixed implicitly, implicitly it will be fixed in a particular location. Let us say if we write 20, so we can write 20.0. If I write 30, that means that point is fixed in this position. So, that is why it is called the fixed position. But if we write it 2.05, this can be written as 20.5 into 10 to the power 1. So, this number is a floating point number. So, in other way around, for representing integer number, that is mostly we say the fixed point number, another is floating point number or real number. So, now in today's class we will focus how we represent the fixed point number, that means integer number, how do you represent integer number. So, sign magnitude representation is very simple. So, if you represent say plus 4, what we do it for sign one bit it will be reserved So, for positive number we put 0 and for negative number we put 1. So, this will be 0 and 4 will be represent 1 0 0, and for negative number negative 4 how do you represent? So, this is 1 and then number 1 0 0 here. So, this number is something, this representation is called the sign magnitude representation. And then what is 1's complement representation? So, 1's complement representation is for negative number it start with -1 and positive number 0, and for 1's complement representation what you do it, for rest of the number you present into 1's complement. Let us say 1 0 0 1 0 0, or let us say I want to represent +3. Okay. So, then what do you do it for representing +3? So, it should be 1's complement representation will be 0 for positive number and 3. If it is negative number, then you represent into 1's complement. Okay. So, negative number will come 1 and 3, 3 means 1 1. So, it take its 1's complement, it will be 0 0. So, -3 is nothing but 1 0 0 for 1's complement representation. Okay. And 2's complement representation is simply you add +1. So, that will give you the 2's complement. Okay. So, now what you do it, we will represent the number in 1's complement and 2's complement for a few numbers, then it will be clear. So, here we have the representation. So, let us say we have the decimal representation, and then we have sign magnitude, and we have 1's complement, and we have 2's complement. Okay. So, let us say number +7, +6, +5, +4, +3, +2, +1. Okay. So, here as you know sign will be 0 1 1 0 1 1 0. So, this will be 0 1 0 1, this will be 0 1 0 0, this will be 0 0 1 1, this will be 0 0 1 0, this will be 0 0 0 1. Now, we have a 0 here, and then we have what is that, -1, -2, -3, -4, -5, -6, -7. Okay. So, how do you represent this set of number here? Now, +0 is what? +0 is 0 0 0 0 sign magnitude, -0 is 1 0 0 0. As you know, there is nothing called +0 -0, but you can have two representation for 0. This is all about 0, but you have two representation for 0. Now, -1 you have to give symbol 1 and then value 0 0 1 1 0 1 0 0 0 1 1, then sorry, this will be 1, then what, 1 4 1 5 1 6 1 1 1 1. Okay. So, that is sign magnitude number. But problem with this representation, as you see, 0 is getting represented into two different combination. Now, 1's complement will remain same here, 2's complement will remain same. So, for positive number there is unique representation across the different representation methods, right, whether you represent in sign magnitude or 1's complement or 2's complement. So, that will be the same. But if you represent negative number, that will differ from one representation to another representation. So, this is we have seen with sign magnitude. Now, we talk about the 1's complement representation of say minus 1. So, how do you get it? So, this is okay. This we should have a special treatment for 0. Now, for minus 1 what do you do? For minus 1 what will be the 1's complement? So, 1's complement will be 1 1 0 and then number is 1. Then minus 2. So, minus 2 will be 1 0 1 0 1. Then what will be the minus 3? So, it will be 1 0 0 1 0 0 and this will be 1. What will be minus 4? So, minus 4 is here. So, minus 4 will be 0 1 1 1. So, minus 5 this will be 1 1 0 1. Okay. 1 0 1 means 0 1 0. Then minus 6 it will be 0 0 1 0 0 1. Minus 7 this will be 1 0 0 0. Okay. Okay. So, what will be the value of plus 0 and minus 0? So, you take the 1's complement. So, 1's complement will be, so here this will remain same 0 0 0 and take the 1's complement, it will be 1 1 1 1. Okay. So, here also in 1's complement you have two different representation for representing 0. Now, come for the 2's complement representation. If you see in 2's complement representation, so you have to, how do you do the 2's complement? You take the 1's complement and add plus 1, you add 1. So, therefore, minus 1 corresponding 2's complement will be, so this is already 1's complement, you add 1. So, this will be 1 1 1 1. Okay. Now, this is minus 1, then minus 2, what will be the minus 2? Here minus 2 will be, you add 1 1 1 0 1. So, this will be how much? 1 1 0 1 1 and then 1. Okay. Then this will be what? You add 1. So, 1 0 1, then you add 1. So, 1 1 0 1 1 0 1. So, here you add 1, what will get it? You add 1. So, it will be 1 1 0 1. Then you add 1, what will get it? 1 1 1 0 0 1. You add 1, say you will get 1 0 0 1. Okay. So, now we come for the positive 0. So, that will remain as 0 0 0 0. Now, what will have with the negative 0? So, this is already we have the number that is in 1's complement. So, you add 1. Okay. So, if you add 1, then 1 1 0 1 1 0 1 1 0 1 1 0. So, this will have also 0 0 0. Okay. Now, what interesting thing we found ki for 0 in 2's complement, whether it is positive 0 negative 0 is only represented with 0 only. So, that is the advantage for in 2's complement representation. For each number there will be a unique representation. whereas here in sign magnitude and 1's complement what we see ki for 0 there are two different pattern. So, in general in computer system 2's complements representation are 2's complement representation is only used. So, therefore, we will be focusing only 2's complement representation. So, in positive number it is same. So, you have to you will have the same representation across the techniques, but negative number it differs, and for we accept only the 2's complement representation. Okay. Now, what we will see it in the next step, we will see how we can perform addition subtraction using 2's complement representation, and we will have the advantage to use the 2's complement representation. Okay. So, as I said, the book is amateur. Okay. So, now how do we add the number in fixed point number representation and especially for 2's complement representation. Okay. So, first we talk about the something is called modulo operation. Okay. We know that modulo operation, what is that. So, one interesting thing we will see, suppose we have a circle here. Okay. So, number will start 0, this will be number is -8. Okay. So, here we will have 1, 2, 3, 4, 5, 6, 7. So, here we have number -7, -6, -5, -4, -3, -2, -1. Okay. So, now what we do it? We represent in 2's complement number. So, this will be 0 0 0 0 1, this will be 0 0 1 0, this will be 0 0 1 1, this will be 0 1 0 0, this will be 0 1 0 1, this will be 0 1 1 0, this will be 0 1 1 1. Okay. So, now this will be 1 0 0, this will be 1 0 0 1, this will be this will be 1 0 1 0, this will be 1 0 1 1, this will be 1 1 0 0, this will be 1 0 1, this will be 1 1 0, this will be 1 1 1 1. Okay. Now, what we do it? Let us say we want to add +4 +3, then simply what we do it? So, we identify the location 4 and then we move to the 3 place. So, 1 2 3. So, results is +7. Now, let us say we want to add number +7 3. So, results is actually +4. So, using this operation, and this is modulo 16 operation, okay, modulo operation 16. Okay. So, what we do it? We identify +7. So, +7 is somewhere here and -3. So, what is the corresponding value of -3? Here -3 is somewhere here, okay, 1 1 0 1. So, what is the corresponding value 1 1 0 1 in binary, sorry, in decimal? What will be the corresponding value? So, it will be 13, right, 1 1 0 0 and 1 0 1. So, this is 8 and this is 5. So, this is 13. What do you do? You move 13 places. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, result is plus 4. So, now you can try for any number, okay. Essentially you will get the right results. Okay. So, this is just fun, you can check the number. Okay. Now, from here what we get the conclusion here. So, to add number, let us say I let me note down the rule. Okay. Add two numbers. Okay. What we do it? Add their n bit representation. So, add their n bit representation. Okay. And what you have to do? Ignore the carry out bit, ignore the carry out bit. Okay. Okay, carry out bit from most significant bit position. So, this sum will be correct, okay, if results are within a range. So, therefore, sum is correct as long as results is within the range what 2 to the power n bit. So, 1 will go for sign bit 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. Okay. So, that we need to check it. So, if the result is within the range, then if we follow, we add the these two number. First we represent the number in 2's complement represent, obviously we are talking about 2's complement n bit representation, and if there is any carry out bit from the sign position, so that needs to be ignored. So, now we will talk about few example here. Let us say, and then another is, suppose you want to do this operation x y. So, in that case what we do it? We represent the number y in 2's complement and add y with x. Okay. So, that we will verify with few example. Say here, let us say we want to add plus 4 minus 6. So, therefore, what we do it? So, one example is we can say plus 4 is 0, 1, 0, 0 and minus 6. This is plus 4 and minus 6. So, minus 6 is nothing but 1, 0, 1, 0. How do you get it? 6 is what? 1, 1, 0. So, take 1's complement 0, 0, 1, you add. So, 1, 0, 0 and then sign is 1. So, therefore, 1, 0, 1, 0. Now, you add it. What will be this value? It will be minus 2. So, ideally this 4 bits. So, what will be the range? Minus 8 to plus 7. So, this should be corrected. So, now you add 0, 1, next 1, 0, 1 and then 0, 1, 1. So, that is nothing but the minus 2. So, what is minus 2? Minus 2 is what? 0 0 1 0. Take 1's complement. So, then it will be 1 0 1, you add 1 1 0 1 1 1 0, right? Yeah, 1 1 0. So, this is done. Now, you take more example. Let us say you take example is minus 5 minus 7. So, minus 5 will be 1 1. Okay. So, minus 5 and minus 2 minus 7. So, it is satisfying. So, now we have to see results. Minus 5 means what? 1 0 1. It will be minus means what? 0 1 0. You add 1 1. Okay. So, it will be 0 1 1, right, and so it will be 1 0 1 1, and then similarly minus 2 will be 1 1 1 0. Okay. Now, you add 1 1 1 0 1 1 0 1 1 1. Okay. So, this is minus 7. Okay. This result is also correct, because this negative number. So, it will be represented here. Okay. Let us try with minus 3 minus 7, whether it is working or not. Minus 3 minus 7 is minus 10, but it should not give the right results. Okay. So, then what do you do? Minus 3 means what? 1 1 0 1, and minus 7 means 1 0 0 1. So, you add it 1 1 0 1 1 1 1 1 1 0, cross it, but this cannot be the positive number, it is actually a negative number. So, therefore, results will be valid only if it is correct results, if range satisfied with minus 8 to plus 7. In earlier example, what we have seen ki minus 7 minus 3. So, it is coming minus 10. Similarly, if you add plus 7 plus 3, so it will come plus 10. So, now if we represent plus 7 is 0 1 1 1 and plus 3 is 0, okay, 0 1 1. So, you add it 1 1 0 1 1, this should be 1 1 1 0 1. So, as you can see, this is coming as a negative number and this is coming as a positive number. Okay. So, therefore, if the results within the range, then it will be correct, otherwise there is something called overflow and underflow. Now, we will talk about overflow and underflow. Okay. So, this is something called underflow and this is something called overflow. So, this is overflow and this is underflow. If there is a overflow or underflow, so we have to correct the results. Okay. So, therefore, first task is to identify whether there is any overflow or underflow, then only we will go for the correction. Now, what we will learn ki how to identify whether after the operation of the addition or subtraction is there any overflow or underflow is there. Please note that. So, if you add only, whether you are adding 2 positive number or 2 negative number, then only there will be overflow, but if is one number is positive, another number is negative. So, there will not be any overflow or underflow. Okay. So, therefore, let us say we have 2 number. So, number is can be represented is like x n, this is the bit of the number x n minus 2, x n minus 3 2 2 2, let us say x 0. So, obviously, this is sign bit, and another number you have y n minus 1, y n minus 2, y n minus 3 to y 0. Okay. Now, what you have to do? Let us say you add these two numbers. When there will be overflow, what if there is any carry out bit from this position. So, that is carry C n minus 2 position. Okay. And then there will be any change here, as you can see here is a change, here it was change. So, therefore, to identify whether there is overflow or underflow, we need 3 bits. One is x n, we need another y n, and then we need the value of C n 2 if there is any carry out bit. Now, in this we should have output. What will be the, after addition or subtraction, what will be the sign of the number? So, output we should have, another is the output will have the detection bit, whether there is any overflow or underflow. Okay. So, this is something called sign bit, or say what we can say is S n minus 1, that is sum. So, S n minus 1, that is sign bit, and then this V is, V indicates that there is any overflow or not. Okay. So, now we have 3 bits. So, then we will get the 3 combination 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Okay. As I said, if there is a addition or subtraction, let's, if you are adding two number plus and minus, so there is no chance for overflow. Let us say highest number you can represent in 3 bit is say 1 1 1. Now, if any number, if you have a number you add with any negative number, so with it negative number you can, lowest negative number it will be. So, let us say what will be the 0 0 1. So, if you give, so this will be plus 6. So, there is no chance for overflow, because this number is already represented in this format. So, only problem will happen when you are adding 2 negative number or 2 positive number, that time only overflow will happen or underflow will happen. Okay. So, therefore, if one positive number and another negative number, there is no chance for overflow. One positive number, one negative number, there is no chance for overflow. One positive, negative, positive, no chance. One positive, negative, there is no chance. Okay. So, I think this is disturbing. Now, if you add two numbers, obviously sign will be, two positive numbers, sign will be remain sign, sign will not change. If you add two numbers, sign should not change here. Similarly, if you add two negative numbers, sign will not change, to add it will not change here. Okay. Now, if you add, so let us say x n 2, x n 3, similarly y n minus 1, y n minus 2, y n minus 3 dot 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 dot, and you add it. When there will be overflow, if from here, that is C n minus 2, you are adding two positive number, if there is any overflow in this position, so that means actually if there is C n minus 2 is 1, so then there is a overflow in this position, and then there will be any problem. So, if it is 0 0, so then it will be 1. Okay. So, in this scenario it is 0 0, because there was a overflow in this position. So, therefore, if C n minus 2, that means there is a overflow. So, therefore, if the number is, both are positive number and C n minus 2 is 1, sign will remain positive, but there will be overflow, and if there is no C n minus 2 is 0. So, then there is no overflow. So, here this will be 0. Okay. That means, in this position if there is C out, carry out bit is 1, then we will say is the overflow, but in so let us say you are adding 0 1 1 and you are adding 0 1 1. So, this is sign bit. Now, you so 1 1 0. So, there is a carry out bit at this position 1 1 1, there is 1. So, this is not a overflow, because from this position C n minus out is not 1. So, it is 0. So, in that case there will not be any overflow, but if in this position let us say this is 1 1, obviously there will be overflow at this position, C n minus 2 will be 1. So, then if we add two number and C n minus 2 is 1, so then there is a overflow. Now, we have to identify here in this two scenario. Now, if you add two negative number and C n minus 2 is 0, then whether there is overflow or not. So, let us say you take one example, let us say we are adding number minus 7 and minus 7. So, as we know that minus 7 minus 2 even though if you do, there is underflow, because here you can represent number minus 8 to plus 7. So, let us say minus 7 and minus 2. So, now we add it. So, minus 7, how do you represent minus 7 in 2's complement? So, this is 1 1 1. Okay. So, then complement is 0 0 0, you add 1. So, therefore, minus 7 will be 1 0 0 1, and what will be minus 2? Minus 2 is generally 1 0. Okay. So, now you take 1's complement 1 0 1, you add 1. So, this 1 1 0 1 1. So, this will be 1. So, now you add number 1 0 0 1 and 1 1 1 0. So, you add it 1 1 1, there is no overflow at this position, right, but there is happening underflow, that is C n minus 2 position is 0. Here there is this no carry out bit is coming, but what is happening? So, we are seeing there is a overflow. So, therefore, if both are 1 1, but there is no carry out bit, okay, sign obviously if you add two negative number it will remain negative, but there is a overflow here. Now, you add minus 2 minus 2, okay, there is no overflow obviously as we can see it. So, now we will check whether there will be any carry out bit at C n minus 2. So, that is we need to check. Okay. So, this is 2, right. So, 1 1 1 0, this is 1 1 1 0. So, now you add 0 1 1 0. So, carry 1 1 1, there is a carry C n minus 2 is 1, but what there is this value is not a overflow value, because it is within the range. So, therefore, if there is a carry out bit, so there is no overflow here. Okay. Now, what you realize that in two cases we will have the overflow if both number is positive, however, C n minus out bit is 1, then there is a overflow, and if both are negative number and C n minus 2 bit is 0. So, then in that case there will be also overflow. Now, what will be the sign if you add positive negative number, what will be the sign? As we know that sign bigger number will have results will have the same sign as that of the larger number. So, then we have to identify here. Okay. So, let us say we are adding one positive number, that is minus 7. So, what is the value of minus 7? So, minus 7 will be 1 1 0 1, right. So, it is 1 1 1 0 0 0, then add 0 1. Okay. So, this is minus 7. Now, you add minus 7 with plus 4, plus 4 is 1 1 0 0. Now, you add it 1 0 1. So, that means, if there is no carry out bit, so then sign bit will be minus. So, now you find 0 1 carry out bit is there, no. So, then this will be sign will be 1. Similarly, you are adding 1 0, sign out bit is there, 0 1 1 0 is same. So, this will be negative number. Now, you add plus 7 minus 4. So, what will happen? Plus 7 is 0 1 1 1, minus 4 corresponding complement what? 1 0 0. So, 0 1 1. So, it will be 1 1 0 0. Okay. Now, if you add this number, it will be 1 1 0 1 1 1 0, and then from here we are getting carry out bit C n minus 2 is 1, but number will be the positive number, right. So, if there is a carry out bit, if we add it, so number will be positive. So, this will be 0. So, 1 0 carry out bit is 1. So, then number will be positive. Okay. Now, this is you got the truth table. So, you can easily generate function for here and here. Okay. So, I stop here for today's class.